All right, so we're going to walk through the study guide for tomorrow's 3A test. This is the study guide 2. I'm going to try to go kind of quick on this, but I'm probably thinking I'm going to have to split this up into 2 different videos. So here's video 1. All right, just like in class today, we need to find our slopes and we need to find our y-intercepts. So the slope is going to be the rise over the run. And I'm going to start because these graphs don't have crosshairs. I'm going to pick a few of those. All right. And then I'm going to do a rise and a run. And it doesn't matter which ones you pick. Now, I do want you to notice that these are counting by twos. So this 2, 4 right here, like your rise is 4, your run is 2 here. So the slope is rise over run, which in this case is 4 over 2, which means my slope is 2. The y-intercept is where our line crosses the y-axis, and so in this case, that would be at 4. For function b, let me fix this, keep it blue. For function b, this is the equation y equals mx plus b, and so my my slope m is going to be negative 1/2, and my y-intercept b is going to be positive 3. For c, you need to find the change in x. So to find our slope, that's going to be the change in y over the change in x, which my y's are changing by 0, negative 2, negative 4. That'll be a negative 2. Negative 2, negative 1, 0. That would be a positive 1, so plus 1. So we have negative 2 over 1 for a slope of negative 2. The y-intercept is going to be when x equals 0. So my y-intercept on this is going to be at negative 4. So we just need to order these from least to greatest by the slope. So the smallest slope that I see is from function c. The next smallest is going to be from function b. And then the largest slope that we have is from function a. For my y-intercept of b, the smallest y-intercept that we have is c. The second smallest is b. Third smallest is a. So CBA on both of them is what I've got there. All right? That's the first one. Question 2, use the given graph to interpret the rate of change and the y-intercept. Just like it was before, we're going to find a rise and a run, and I'm going to find some crosshairs. So it looks like these are our crosshairs. Now our rise is not negative 2 and run being negative 1 on this one. What it's going to be is from crosshair to crosshair. Here's what I'm going to do. I see that like these boxes are not counting by ones, they're counting by like a half. So I'm actually going to go down to this 4. And then I'm going to go right to whatever this is, because I know that this change right here is a negative 1. Even though it's 2 boxes, the change is negative 1. And then we're going from noon to 2 o'clock, which is a 2-hour time difference, right? So my rate of change, how I would describe that, is I would say that it's slope, which is m, which is rise over run, but it's going to be a negative 1 over 2, which in the context of this problem means the depth decreases 1 foot, I guess, every 2 hours. All right, so that's where I get that. And then my y-intercept is at 5. And what that means is the 5 is going to be the starting depth. Let me put this down here. The starting depth of water. There we go. That's the front page. Second page. After this page, I'll probably end this first video. It says Russell's at the store, which is 12 miles away from his home. Seems like a similar setup to the A study guide. If he can travel 4 miles per hour, how long will it take him to get home? So it's almost the exact same thing. First off, we need to label X and Y axes. So miles will be our Y. X will be hours, time. He's starting at 12 miles from his house. He can travel 4 miles per hour. So what that means, 4 miles per hour. And he's trying to get home, so his miles are going to decrease. So it'll be 1, 2, 3, 4. 4 miles every 1 hour. So that would be his next position. And then he'll go 4 miles closer. 1, 2, 3, 4 every 1 hour. And then he'll go 4 miles closer every 1 hour. So this is what our line should look like. Maybe, if my pen will work. There we go. That's what the graph should look like. The rate of change is 4 miles per hour. So what's his name? Russell. Russell travels here we go. Four miles closer to his home each hour. And then the y-intercept is that starting point, so 12. So Russell starts miles away from his home. Okay, there we go. This next one, graph the points or graph the function, and then we'll test whatever points we don't actually hit. So I'm going to start by graphing this equation. And so I'm going to start with my y-intercept of 2. Would be on the y-axis here. And then my slope is 3 over 4. So that means I'm going to go up 3, right 4. So 1, 2, 3, 1, 2, 3, 4. I'm just going to keep doing that. 1, 2, 3, 1, 2, 3, 4. I can't go any farther, so that's where I'll stop. And I might actually, you can remember you can go down 3, left 4 as well. So maybe that's what I'll do. Down 3, left 4. From my y-intercept, down 1, 2, 3, left 1, 2, 3, 4. Down 1, 2, 3, 1, 2, 3, 4. That seems like that's all we got. So no big deal. Just try to graph this. Remember, your lines should go all the way across the graph like that. Okay, so let's see if there's any that we can test. 0, -2, we can see that on our graph. 0, -2 is here. Notice that our graph does not go through that, so that one will not work. 4, 5. So if I check the location of 4, 5, from the origin go right 4, up 5. That's right here, so that actually will work. And 8, 6. So if I from the origin go right 8, up 6, where is that? That will not fit. That's here. So that one's not going to work either. So we do have to use that method that I showed you in class for the other ones. Actually, maybe not. 10 and 9.5. Where's that? 10 and 9.5. I would be willing to bet that that does work, but I am going to try that one. So these three on the right, I'm going to use that method where we use this equation right here. So I'm going to write that equation. And then I'm going to substitute in these numbers. So this 9.5, I'll use 9.5 for my y. The x would be 10 plus 2. And I'm going to type everything into a calculator. So 3/4 times 10 equals 7.5 plus 2 is 9.5. Okay, so it did work. It did work. So that one does check out. And then I'm going to just kind of keep using this method. So 14 is going to go here. Slope of 3/4, 16 plus 2, 3/4 times 16 plus 2. Whoops. Oh my goodness gracious. 0.75 times 16 is that plus 2 is 14. 14 does equal 14. That'll work. And then 12/7, that'd be my last one. So 7 is my y, slope of 3/4. 12 is my x in that one. So 3/4 times 12 is 9 plus 2 is 11. Yeah, that one's not going to work. So, nope, does not work. Therefore, those are the only three that we have. In terms of our what else could work with these, honestly, anything that we've used on this line could work. So 4, 5 was already there. We could use 8, 8. That would work. We could use the actual y-intercept, which is 0, 2. We could use, looks like -2, -3, -4, -1. And then the last one on here, which again, you could pick any that you want. You would just have to use the equation for it. But the last one on here that I see is -8, -4. So no real math required on those, just picking out those crosshairs that we have for that. Okay. And on that note, I believe I'm going to stop this first video as to not do too much for you here, and I'll be back with a second.